let's get started. So today we're going to be learning about radical equations, okay? What is a radical equation? A radical equation is an equation that has a variable in the radicand. So the radicand is going to be that variable that is under the radical sign, okay? It's variables, numbers, whatever. It's going to be under the radical sign. So radical equation is going to have a variable in the radicand, okay? So here's our example. We have the square root of x plus 2 is equal to 18, okay? And that is because we're going to be solving for x, and since x is in the radical, that is what makes this a radical equation. An equation with a radical is going to be when there is a number in the radicand, okay? If it's just a number and there's no variable, it's an equation with a radical. So here's your example for that. You have x over there, perfectly good x, and then you have your irrational number over there. Okay, let's talk about inverse operations for a minute. An inverse operation is a mathematical operation that undoes another operation. Now, I feel like that's bad grammar, but whatever, bear with me. Okay, so the inverse operation of addition is subtraction, and the inverse operation of multiplication is division. So the inverse operation of a square root is not that square. It's this square. Okay. Let's do some practice. Okay, we have our first example. The square root of x is equal to 5. So we talked about our inverse operation, and what we do to one side we have to do for another, because that is just the nature of equations. So we're going to square one side and we are going to square the other. That way we can get rid of our square root. So that is what that is going to look like. Okay, I just took my the side that has x with the parentheses, put parentheses around it, and then squared it, and then I'm squaring the other side as well. So my square root and square cancel, and I'm just left with x is equal to the square to 5 squared, which is just 25. Okay, we're going to be doing the same thing with example 2. I am taking each side and I'm squaring it. So notice how with -6 I covered that with parentheses and then I squared it. I didn't leave the negative on the other side and made this I'm not going to make it a -36, okay? It's going to be a +36 because it's the entire quantity of that side. I'm just going to wrap that whole thing in parentheses and then square it. The next thing that you need to do is check your answer. Why is that? Well, let's take a look. If we plug in 36 into the original equation, okay, I have the square root of 36 is equal to -6. Wait, what? The square root of 36 can never equal -6. We know that from the previous lesson. It doesn't work out like that. So there is no solution for this problem. And just a little tip, okay? If you see a problem and you've already isolated your radical, we'll talk about that in a moment, but when you isolate your radical and you have a negative number on the other side of your equation, there will be no solution for square roots, and that's what we're dealing with in pre-algebra. Okay, steps for solving radical equations. First step is to isolate the radical on one side of the equation. What does isolate mean? It means you can't see your grandma during this quarantine, right? She's isolated. She is by herself, okay? Isolating means you want something by itself. So in this case, we're going to have radical x on one side of the equation. Your second step is to square both sides of the equation. Okay, both sides, not just one side. When you square the square root of x, you have to square root the other side. Then you're going to solve the equation like you normally would, and then you will check the solution. let's look at some practice problems. Okay, number 1, the square root of 3x plus 2 is equal to 8. I know this looks a little different, but don't panic, we can totally do it. Our first step, we said, was to isolate the radical. So I need to get that radical by itself, and that means I am, okay, let's see, here's our x, right? That's what I'm trying to get to, that is my end goal. So I need to move who out of the way? Who? -2. I gotta move the 2 out of the way, so I'm going to subtract both sides by 2, and then I am going to get the square root of 3x is equal to 6. Okay, those 2's cancel. 8 minus 2 is 6. Now I have isolated my radical. I need to square both sides. Okay, I have my hands like this because I'm reminding you to use parentheses. So I'm going to square both sides, and the square undoes the square root and undoes whatever. So I will be left with 3x is equal to 6 squared, which is 36. Now I'm going to solve this like I would a normal equation. I see that this is 3 times x is equal to 36, which means I need to use which operation to undo that multiplication? That's right, I'm hoping you said division. I'm going to divide each side by 3, so I am left with x is equal to 12. Okay, if I'm going too fast, please feel free to pause the video. That's the beauty of this YouTube. Okay, next problem. 4 times the square root of 2x plus 1 is equal to 24. First step, isolate the radical. This case, I am not going to be adding or subtracting to isolate. I'm going to be, well, getting rid of that 4. And if that's 4 times the square root of that nonsense, how am I moving that 4 over? I'm going to divide. I'm going to divide both sides by 4 in order to get this x. Okay, let's do it. I'm going to divide that side by 4. I'm going to divide that side by 4. And then I have the square root of 2x plus 1 is equal to 6. Now that I've isolated my radical, my next step is to square both sides. Okay, I'm going to square the side with my radical, and I'm going to square 6. So let's square that guy. Let's square our 6. And then my square undoes that square root sign. I'm left with that inside, which is 2x plus 1 is equal to 36. Now I'm going to solve this like I would a normal equation. So my first step is to subtract 1 from both sides. Then I will be left with 2x is equal to 35. Then I will divide each side by 2, and that is x is equal to 17.5. So that's it for today. You have more practice in your book. If you have any questions, please let me know, and have a very blessed day.